Okay, right. In this question, we are asked to find that DGFO is a cyclic quad. That's the first thing. We are given that DE is a diameter, and you can see it forms a 90-degree with AC. And therefore, it follows that AB must also be a diameter. Now, if we want to find that DGFO is a cyclic quad, that's our first task. We've got to show that it meets the properties of a cyclic quad. And therefore, we look for things like opposite angles inside the cyclic quad. Inside the quad, are they equal, or do they add up to 180 degrees? If so, then we've proven by the converse that we have a cyclic quad. So let's check it out. Angle DOF is 90 degrees, that's given. Now, if we can prove that DGE or DGF is equal to 90, and then we've proved our contention. But hang on, if you look at it, if DE is a diameter, DGE is an angle that is subtended by a diameter, and therefore DGE is equal to 90. And therefore, we've proven that it's a cyclic quad. If DGE is 90, 90 plus 90 equals 180, and therefore DGFO is a cyclic quad. That's the first one proved. And now once it's proved that it's a cyclic quad, we need to then say, okay, the properties of a cyclic quad hold. So if you look carefully at the sketch, you'll see that angle GFB is the exterior angle of that cyclic quad, which means that the exterior angle must be equal to the interior opposite. So in other words, F1 is equal to angle D, and perhaps we're going to be using that a little bit later. The second question was to prove that GC equals FC. That's the task. So FC and GC. Okay, so let's have a look at it and see. So if those two sides are equal, then it must mean that the triangle GFC is an isosceles triangle. And if it's an isosceles triangle, it means, therefore, that angle FGC is going to be proved to equal angle GFC. And so let's look at it now. And we'll see here that angle, GC is a tangent to the circle, and therefore the angle between a tangent and a chord, there's a chord, GC. The angle between the tangent and the chord is equal to the angle in the alternate segment. So in other words, this angle FGC must be equal to angle D. But hang on, the thing we've just spoken about previously, angle GFC is the exterior angle of this cyclic quad, and we've already proved that because it's a cyclic quad, angle GFC is equal to angle D. And therefore, both of them are equal to angle D, and therefore they are equal. If they are equal, we've now proven that FC equals GC. Now, that's the first part. First two questions sorted. The second part of the question is, given that CO equals 11 and DE equals 14, calculate the length of BC. Well, we are given that OC is equal to 11. If OB is a radius, and that is 7, 11 minus 7 equals 4, and therefore we've calculated that angle BC is now equal to 4, and so that problem is sorted. Now, the second question in the second part, the length of CG or GC. Now, and yet it's 5 marks, so there's some work to do, and we notice that GC belongs to triangle GBC. It also belongs to triangle GAC, and we notice that that angle C belongs to both triangles. Now we've got the length of BC, we've just proven it. And so we've got a length there in that triangle, and we can calculate the length of A up to C, which is just the diameter plus 4. So AC is going to be 14 plus 4, which is 18. So let's see if we can use that. In other words, if we can find that we've got one pair of angles equal, if we can find another pair of angles equal, and then we've got similar triangles. So let's just have a look at it. Angle BGC. There's the tangent. The angle between the tangent and the chord is equal to the angle in the alternate segment. So that angle G1 we've just shown is equal to angle GAC. And so this angle is equal to that angle. We call it X if you want to. And therefore we've shown that triangle GBC and GAC are in fact similar because there are two pairs of angles that are equal. And therefore it just means that we have to write it down carefully to show that the corresponding angles are in fact equal, and that's how we write our similar proportions. So therefore GAC is similar to triangle GBC. Take note, angle C equals angle C, and we've shown that angle A is equal to angle G in the smaller triangle. Okay, and which means the other letter has to be equal. So therefore we write it in this order, GAC, that is the bigger triangle. Let's just go over here quickly. GAC, the bigger triangle, is similar to the smaller triangle there, like that. So this angle G, the bigger one there in the bigger triangle, is equal to that angle B. And therefore the triangle, if we note it here, G and the corresponding B for the smaller triangle. And once we've got it in the correct order, that C belongs to both triangles, then we can form a proportion such that if you look at it, GC is going to be incurring in both. So there's a GC and there's a GC. So there's a GC, and therefore there must be, if those two letters go, the last two go together, then the last two go together here. To get a GC here, it's the first and the last, and therefore B and C go together. And so to form the proportion, GC, which is the bigger one, over AC is equal to BC, because you have to do the same thing there and the same thing there, as BC over GC. And if you look carefully, if you cross multiply, you'll get GC squared, and cross multiply that way, AC times BC. But hang on, AC we've just got as 18, BC is 4, which means that that comes to 72, and square root of 72 is therefore going to give us GC, and that is actually what we wanted. So now that we've got GC, look carefully, we've got that equals 8,49, which means this is FC is 8,49 minus 4, which gives us FB, which will be 4,49. And if OB is a radius, that's 7 minus 4,49 gives us 2,51. And we notice that OE is a radius as well. That angle must be 90 degrees. And therefore, we can find angle E, which is the last question. And you notice in that particular triangle, opposite it is OF, which is 2,51, and adjacent is OE. And therefore, the tangent of angle E is going to be 2,51 over 7. Angle E, therefore, is arctan 2,51 over 7, which gives us an angle of 19,73. Thank you.